Math 3, Unit 2, Section 2. Today we're going to talk about solving and graphing absolute value equations. Okay, so we remember that the graph of an absolute function looks like this. Okay, also sometimes we might even write it like this: y equals a, absolute value of x plus 0 plus 0. The value of a determines the width and the direction of the graph, because we can use the slope with absolute values because we're dealing with two different lines. Okay, so what we're going to be doing today, and here are steps for solving absolute value equations algebraically, but we always set the absolute value or get the absolute value by itself on the left side of the equation, and then you'll end up making two equations. And the reason is because inside the absolute value you could have a positive number, and when it comes out it's positive, and inside it can be a negative, and when it comes out it's a positive. Okay, always it comes out as a positive. Okay, so let's start by graphing this first. Okay, so if I were to graph my f of x equation, where would I go first? My vertex would be at what? 4, 0. Very good. And so we're going to go right 4 and up 0 and make a point. And then what is my slope on this one? 1. The slope is always in front. If there isn't a value there, it's 1, and specifically that is 1 over 1. Now when we're graphing and solving these, you want your graphs to be as perfect as possible. You might want a ruler, or like if you have an index card or something, you could use it. But we're going to be going up 1, right 1 a bunch of times. I want to make sure this is accurate, and I'm going to same thing on the left side, but it's going up 1, left 1 to make my symmetrical graph. And then I'm going to draw my straight line, hopefully, because we're going to try to find the point of intersection on this graph, and so that's why we want to make sure it's perfect. Okay, so, and I'm going to label that one, and that is f of x. Okay, questions so far? We're all good there? Okay, now my other equation is with g of x, and it just says g of x equals 3. That is the same thing as saying what? Very good, y equals 3. So where will I go to graph that? So we're going to go up to 1, 2, 3 right here, and I'm going to draw my line. And that one is labeled as g of x. Do you see how there are two different points of intersection? And again, my graph was not exactly perfect, but you can see there's a point of intersection here and here. Do you guys see that, where the two lines meet? Those values are at 1 and 7. Do we have questions before I move on? Okay, so now we're going to do the same thing, but we're going to solve it algebraically. So all we're doing is we're taking the f of x equation. Well, f of x was the absolute value of x minus 4, correct? So absolute value of x minus 4 equals g of x. And g of x was what? 3. So all I did, this said to solve algebraically, put f of x equal to g of x. F of x over here is absolute value of x minus 4. And then g of x is 3. So that's how I got this equation right here. Okay? Do we have questions? So, is the absolute value by itself right now? Yes. Do you see how there's nothing adding, subtracting, multiplying this absolute value? It's just the absolute value on the left side. That's at the point when you'd write two equations. So I'm going to make two equations. I'm going to write this as x minus 4 equals 3 and x minus 4 equals negative 3. And then we're going to solve. So here I add 4 to both sides, and I get x equals 7. Here I add 4 to both sides, and I get x equals 1. What do you notice about the two different, the graph versus the equations? Did you notice that we got the same answer? Yeah. So graphically it's showing you this is where the two graphs intersect, and over here algebraically it's showing you the same two answers. Destiny, go ahead.
Why did you make it negative?
So remember that if I, for instance, had the absolute value of 5, that answer is 5, correct? If I have the absolute value of negative 5, that answer is also what? 5. And so what we do is, once the absolute value is by itself, okay, we write, because inside here, this could be a 3, and when it comes out, it's a 3. Or inside here, it could be a negative 3, and when it comes out, it's still going to be positive 3. And so that's why we always need to write two equations, because inside our absolute value, it can be positive or negative, but when it comes out, it'll always end up being a positive. Now, if you wanted to check these answers, if I were to plug 7 in here for x, the absolute value of 7 minus 4, you simplify inside first. 7 minus 4 is 3, and the absolute value of 3 is 3. Okay, if I plug in 1, the absolute value of 1 minus 4, well, 1 minus 4 is negative 3, and the absolute value of negative 3 is 3. So there are two different numbers, 7 and 1, that will end up getting you the answer of 3 to this equation.
Why would we change the formula like x plus 4?
So you don't ever change that. You don't ever change your equation, okay? All they're saying is that this equation can be 3 or this equation can be negative 3 in order to get the same answer with the absolute value. So the only thing that is once you have the absolute value by itself, this number is going to be a positive and also a negative. Okay? So let's try the next one. Are we ready? Okay. So if we start with our f of x, okay, what is my vertex for that problem? Very good. Negative 2, 0 is correct. So we go negative 2 up 0. And then what is my slope? Good. Negative 3 over 1. So from this point, I'm going to go negative 3, right 1 and left 1. And then we're going to go negative 3 again. And we're going to go negative 3, left 1 and right 1. Okay. And then I'm going to try to draw a good line again. So remember, absolute value is two lines that make a V. Okay, so there's f of x, and we're going to label that as f of x. And then next we have g of x. And what is my equation for g of x? Good. And specifically, y equals 2. So we go to y equals 2 right here, and we draw our line. And where do these two graphs intersect? They don't. So this one is no solution. Or if you want to write a 0 with the line through it, that also works. And so when we do this one algebraically, let's see what it looks like algebraically, what a no solution problem would be. Are you guys ready? Okay. So f of x is negative 3 absolute value of x plus 2. So that's where I got that part. And it says f of x equals, and then g of x. And what is g of x? 2. Okay, is the absolute value by itself right now? No. What's in front of it? A negative 3. So what am I going to do to get the absolute value by itself? Very good. Divide by negative 3 is correct. You don't set up your two equations until the absolute value is by itself. So when I do that now, I have the absolute value of x plus 2 equals negative 2/3. Now this is why you always want to check things, and that is that when you start with your absolute value, will an absolute value ever equal a negative value? No. And so this answer is no solution. Now, when we set up the negative equation here, that was because inside here it could be positive and it comes out as a positive, or inside here it can be negative and come out as a positive, but it will never be in here and come out as a negative. That will not happen. Okay, do we have questions there? All right. Example 3. Okay, so we're going to go ahead and start with our f of x graph. And what is my vertex for this f of x graph? Good, negative 1, 5 is correct. So we're going to go negative 1 up 5, make our point. Okay, what is my slope on this one? 1, 2. So that means I'm going positive 1 and then right and left 2. So we're going up 1 and then right 2 and up 1 and left 2. Are you saying something to me or no?
No, I was
okay.
I said why was it negative? I said we were switching it.
Okay, so I'm going to go ahead and draw this. If you made an extra point, that's probably better, but we're just going to do this. Here we go. Okay, so f of x, make sure you're always labeling your graphs. So that's f of x. Next, I have g of x. And what is my equation for g of x? Very good. Y equals 5. So we go up to 5 and we draw our line. And what do you notice? It does intersect at how many points? Just 1. Okay, and whenever you're giving the point of intersection, we are always stating your domain values, your x values. We pretty much always use domain for our answers when you're doing intervals, all that kind of stuff. Okay, and so the x value there is what? Very good. So that answer is negative 1. X equals negative 1. So let's check to see, because our other ones we had 2 answers or no answers. So what happens? How do you just get 1 answer with absolute value? Does anybody know? No, it's a good guess though. Okay, let's go ahead and check it out and see what happens. So we're going to do f of x. So we have 1/2 absolute value of x plus 1 plus 5 equals, and what is g of x? 5. Good, 5. So is the absolute value by itself? Yeah. What will we do first? Good, subtract 5 is correct. So this cancels out. I have 1/2 absolute value of x plus 1 equals 0. Is the absolute value by itself? How do I get rid of that fraction? Very good. Multiply by the reciprocal. So I'm multiplying by 2 over 1, or just 2 to both sides. When I do that, that eliminates this fraction. See how everything cancels out? The absolute value of x plus 1 is by itself now. And what is 0 times 2? 0. So why can't I set up 2 equations here? 0, 0. Very good. It's not positive, it's not negative. So when you get just one answer, it's when the equation ends up being set equal to 0. So we would just set up our equation now, and we have x plus 1 equals 0. We subtract 1 to both sides, and x equals negative 1. So again, do you see how we got the same answer either graphically or algebraically? Yes? Okay. We are going to skip this example. Just so you have the answer if you want to go back and try it later. This one, the answer is negative 1 and 3. And we're going to move down now to example 5. So part of your homework, you're doing both the graphically and algebraically, and then part of it, they're just going to have you solve the absolute value equations. Okay? So here, what would I do to get the absolute value by itself?
Subtract 5.
Good. Subtract 5 is correct. Absolute value of 2/3 x equals, and 13 minus 5 is 8. At this point, now that the absolute value is by itself, also it equals a positive number, I set up 2 equations. Okay, and so I have 2/3 x equals 8, and 2/3 x equals negative 8. Again, what do I do to eliminate this fraction? Very good. Multiply by the reciprocal. So I'm multiplying by 3 over 2 to both sides. Okay, when I do that, that eliminates here. For the 8, I sometimes will put it over 1 just so I can see my numerators and denominators better. And I like to reduce first. If you like to multiply then reduce, that's fine. But I notice here that 2 goes into 8 how many times? 4 times. And so I get x equals what? 12. Okay, on the other side, I'm going to do the same thing by multiplying by the reciprocal, which is 3 over 2. Here these cancel out. Again, I'm going to put negative 8 over 1. I can reduce anything on the bottom with anything on the top, so that ends up making that a negative 4 when I reduce. And so x equals negative 12. Now, if they want you to plot this on a number line, all you would do is make a mark for negative 12 and a mark for 12, and these equal those points. So it would just be a point at each of the values. You can mark a 0 in the middle if you wanted to. Okay, number 6 is kind of tricky. Some people mess up on this. So I want to make sure you guys understand this. This 4, it's not going 4 minus 2. Because this negative 2 is connected to the absolute value, okay? And so just like over here, how we subtracted 5 first, you are going to do what over here? Very good. Subtract 4 first, okay? Because we're trying to get the absolute value by itself. I get negative 2 absolute value of 3x plus 5 equals, and negative 6 and negative 4 makes a negative 10. What would be my next step? Very good. Divide by negative 2 to both sides. These eliminate. Absolute value of 3x plus 5 equals what? 5. Does that work? Is the absolute value equal to a positive number? Yes. And so at this point now, what do I do? Good. Make your 2 equations. So we have 3x plus 5 equals 5. And then my other one is 3x plus 5 equals negative 5. Very good. And we're going to go ahead and solve. So to solve here, I subtract 5 to both sides. 3x equals, and what's 5 minus 5? 0. And then we divide by 3 to both sides, and 0 divided by 3 is 0. Am I going too fast? You're okay? All right, other equation, I subtract 5 to both sides. What is negative 5 minus 5? Very good. Negative 10 is correct. And then we, good, divide by 3. And so x equals negative 10 over 3. Which number is smaller, 0 or negative 10 over 3? So over here, I'm going to mark negative 10 thirds on the left, 0's on the right, and there is a point at each of those values. Any questions? Okay, last example. Okay, based on what we learned there on number 6, what will I do first to this problem? Very good. Subtract 7 is correct. We get negative absolute value of x plus 1 equals 9. Don't lose the negative that's in front of that absolute value. What will I do now? Very good. We're dividing by a negative 1 because really there's a negative 1 in front, right? When there's just a negative there. I divide by negative 1 to both sides, so that makes it a positive. Absolute value of x plus 1 equals negative 9. Very good. And why is this no solution? Right. This absolute value can't end up getting you a negative. You can have a negative inside, but it will never come out and be an actual negative. So this one is no solution. So can you graph a no solution? No, because there's no point on the graph because there isn't an answer. Okay, any questions?